This is problem 7, chapter 12, and we're asked to calculate the location of the center of mass. The center of mass of this object, which has 3 of these masses connected together by rods, but the rods are massless, so we're going to ignore them. We just have to worry about these 3 objects. This is a 200-gram ball here, A, and notice that's at our origin of our coordinate system that is given to us, so the origin is right here. This is a 100-gram particle C, and this is 300 grams, so different masses. Now we know the center mass is going to be closest to the most massive object, but we don't know exactly where it is, and it's in 2 dimensions, so we got to do each dimension separately. What I'm going to do over here is write our coordinates, so since we already have this coordinate system set up, let's write down, well, A is right at the origin, so it's got coordinates of 0, 0. B is up here, it's at a coordinate of 12 in the x, 10 in the y, and C is at 10, 0. I'm sorry, 12, 0, because it's over 12, no y dimension at all. All right, now we're just going to use our equations, but we have to do x direction separate than y direction. So in the x direction, we're going to have the mass total, x center of mass, is going to be equal to MA RA plus MB RB plus MC RC. Or we're going to solve this for the x center of mass, so we're just going to do 1 over the mass total times this whole thing. But now let's look at this. MA, the mass of A is 200, but its location is 0, so this is just 0. Okay. And in the x direction, so that's the only one that's 0. Now for B, we have to do the mass of this, so this is going to be 300. Notice I'm not converting from grams. That's okay, as long as my mass total is in grams too. The grams are going to cancel out. And I'm going to leave it in centimeters because that just means my answer will be in centimeters. You could convert if you want. It's all right. So the mass of B is 300, and then we need the radius of B, and remember these are only in the x direction, or the distance in the x direction. So that's 12 plus C, which is 100 times 12. Okay, and so the x center mass is going to be equal to 300 times 12 plus 100 times 12, but then we're going to divide by the mass total, which is equal to 200 plus 300 plus 100. And when you do all that, you get the x center of mass is equal to 8 centimeters. Okay. Now, in the y direction, we're going to do that the mass total, y center of mass, is equal to MA RA in the y direction plus MB, RB y plus MC RCY. Okay, or the y center mass is going to be equal to 1 over the mass total times this, and we're going to plug these in. The mass of A is 200, but again it's 200 times 0, so that's just going to go away. The mass of B is 300 times its y coordinate, which is 10, plus the mass of C, which is 100, but it's also got a y coordinate of 0, so that goes away. So the y center mass is actually very easy. It's just going to become 300 times 10 divided by 200 plus 300 plus 100, or essentially divided by 600, and you get y center mass is equal to 5 centimeters. So our answer is the center of mass is at a coordinate of 8, 5. Now let's look back and see if that makes any sense. Now if you look here, 12 centimeters is how far these are from the center here. If this was uniformly distributed, it would be half of 12, it would be 6. But since there's more mass further away, 8 makes sense. It's further towards the more massive side here in the x direction. Now in the y direction, it's 5 because you look, this is 300 grams here, But if you add these together, 200 and 100, that's 300 here. So essentially they balance each other out in the y direction. It is exactly halfway between those, or at 5 centimeters. So if you're going to plot this, it would be about, the center of mass would be actually about here for that 3-body object. All right, that's it for problem 7.